properties of cathode rays. Welcome to this educational video where we will explore the properties of cathode rays through various experimental observations. Cathode rays, discovered in the late 19th century, are streams of electrons emitted from the cathode in a vacuum tube. These particles possess remarkable characteristics, and scientists like Thomson and Robert Millikan have conducted groundbreaking experiments to study them. Let's dive into the key properties of cathode rays based on experimental findings. Travel in straight lines. One of the earliest observations is that cathode rays travel in straight lines. This can be demonstrated by placing an opaque object like a metal cross in the path of the rays within a discharge tube. A sharp shadow of the object forms at the end opposite the cathode, showing that these rays emit from the cathode and travel in straight lines. 2. Cathode rays have mass and kinetic energy. Cathode rays are not just light. They are particles with mass and kinetic energy. When a light paddle wheel is placed in their path, the wheel rotates, suggesting that cathode rays transfer momentum. However, it's worth noting that there is some debate over whether the rotation is due to the heating effect of the rays, but it provides strong evidence of their particle nature. 3. Cathode rays are negatively charged. When an electric field is applied to the path of the cathode rays, they are deflected toward the positively charged plate, proving that these particles carry a negative charge. This was further confirmed when scientists observed how the rays deflected under a magnetic field, behaving just like other negatively charged particles. This leads us to conclude that electrons, which make up the cathode rays, are negatively charged. 4. Independent of the gas or cathode material. One fascinating discovery was that the nature of cathode rays does not depend on the type of gas in the discharge tube or the material used for the cathode. This universality suggests that the particles in cathode rays are a fundamental component of all matter. 5. Charge to mass ratio, EM ratio. Regardless of the type of gas or cathode material, the charge to mass ratio, or EM ratio, of cathode rays was found to be constant. In 1899, J. Thomson used this finding to propose the famous plum-pudding model of the atom, where electrons were thought to be scattered throughout a positively charged sphere. 6. Measurement of electron charge. In 1909, Robert Millikan conducted the oil drop experiment, where he succeeded in measuring the charge of an electron as *1.602 to 10⁻19 cc. With Thomson's charge to mass ratio, the mass of an electron was calculated to be 1/1837 or 10⁻37 of the mass of a hydrogen atom, the lightest known atom. This revealed how incredibly small and light electrons are. Thus, through these observations and experiments, the electron was established as a fundamental, negatively charged particle, revolutionizing our understanding of atomic structure. Thank you for joining us as we explored the fascinating world of cathode rays and their contribution to the study of atomic physics. Make sure to like, subscribe, and hit the bell for more science content.